Cool. You can put your phones away now. Sorry, you're in this room. You don't get let out. Okay, so you're here to see some tools in action, and we're going to go through a bunch of tools about a thing called an SBOM. Who's heard of an SBOM? Okay, who knows what an SBOM is? Ooh, probably the same set of hands. That's cool. Okay. Well, let's do the introduction. We only got 30 minutes, haven't we? Yeah, so we'll ignore that. Okay. So this is me on that side. My name is Steve Poole. I'm the director of the developer advocacy group at Sonatype. We are the people who do Maven Central, Nexus, and stuff like that. So secure supply chains. So I am deeply involved in this whole SBOM story, and I have some Maven Central things to show you about SBOMs and related tools.
And I'm Olimpiu Pop. Currently, I just took the role of Chief Technology Officer for a consultancy company in Romania that is doing product software engineering for mostly the German market. And I like talking about weird stuff with Steve. So,
yeah, cool. Okay. Ooh. Why are we here talking about SBOMs? We're talking about SBOMs because it's a way of solving a particular problem. And that particular problem is that we're really not very good at secure systems. And we're so bad at secure systems that cybercrime, which is the driver of all these security issues, has been driving so fast. And the amount of money that the bad guys make out of this has also risen so fast. And a few years ago, when I started talking about security, we were talking only about $450 billion, okay, which is the same, and it's basically the same now, as the whole of the drug trade. So all the illicit drugs that you see, all the TV things about, programs about drugs and drug dealers and amazing movies, that's worth $450 billion to the bad guys. Can you see? Cybercrime. 8.4. Well, it's growing. Trillion. We've reached the point now where the amount of money being made by the bad guys has gone out of all proportion. There is no sign of it slowing down. And currently, if it was the country by GDP, it would be the third largest one in the world. That's how bad the problem is. And though SBOMs are not the complete solution, there is a good reason why they are being seen as part of this. And we're going to talk a bit about that. And then we're also going to talk, obviously, about the tools that are involved. And the more questions you ask, the more fun it'll be. Right, what comes next? Oh, yeah. Supply chains. So again, where's an SBOM come from? SBOM is about code. It's about packages, about knowing what you've got. It's a bill of materials. And the reason this is important is because it's all about the supply of software. Because the bad guys are trying very hard to get into open source projects. They're trying to get into your build systems. They're trying to compromise your supply chains. Hence why we've seen this enormous increase in supply chain. Now, when we talk about supply chain, mostly we talk about CI/CD systems, from code to deploy. That's the supply chain. But we also think about supply chains as the stuff that you depend on, the code that comes from somebody else. They have their own supply chains, and these things link together, right? We are being attacked. We're being attacked by people trying to get into our build systems. They're trying to get into the build systems of the open source projects. And as you can see, 3.4 billion vulnerable downloads are avoidable each month. Okay, so we're in this really bad situation where we have some really bad guys knocking at the door, making loads of money out of us. And of course, now it's a matter of, well, what can we do about it? Yeah. So if you're involved in finding vulnerabilities, right? If there is a problem and somebody says to you, hey, Log4Shell, okay? Log4Shell, everybody's heard of Log4Shell. Anybody not heard of Log4Shell? Trick question, anybody not heard for it? Okay, right, it's the perennial thing. It's the worst vulnerability ever. And still today, from a Maven Central point of view, 31% of downloads, you know, this big number back here, 3.4 billion, right? Well, as far as Java Log4J is concerned, 33% of the downloads are for vulnerable versions. So if you think that you are safe because your scanning tools, those tools that you rely on to check what you've got or what vulnerabilities you've got, if they say everything's okay, they may be lying. So if you think about what you want a scanning tool to do, it starts to become complicated, and you can see why it is that, in fact, the scanning tools are not the best solution we have. And that's why we're going to have SBOMs. We're going to talk about this. So you've got a scanning tool. Anybody, you've heard of Dependabot? Yes, everybody's used Dependabot. Dependabot scans first level, direct dependencies. It looks at those dependencies, looks at the version numbers that you've declared, and it goes off to a public database where it says, this thing, 3.4, is vulnerable. And if you're lucky, it may even tell you what the vulnerability is. And so you get told this thing is vulnerable, and you update it. So that's cool. That's the things that you specified, right? So when you start thinking about it, it's like, well, where is this code though? Right? Where else? When you can look at a POM or you can look at package.json, that's okay. But what happens if the code isn't that obvious? If it's not a direct dependency, it's a transitive dependency. Do your scanning tools look at the dependencies of the dependencies of the dependencies? Can they do that? And what about situations where the code is more than just the vulnerability is, how should we say, more malignant? There are lots of places where the bad guys are trying to insert bad code into other jar files. So one of the classics is they'll look at your build system, they'll get into your open source build system, and at the last point where the zipping goes on, they'll insert something. Right? So are your scanning tools able to scan all the different places where code would be? Can it look in an RPM? Can it look in a jar file? Can it look in a jar file inside a zip, inside a jar file, inside an NPM, inside a Docker container? Can it do all that? Can it figure out where all your code is? And then, having found all the code, how good is it identifying that that piece of code is actually vulnerable? Because quite often, about as a POM level, the scanning tools aren't looking at the binaries, they're just looking at some numbers in a file. But that's not good enough, because nowadays you need to find bad code. You look for Log4Shell. One of the classics was one of the bad pieces of code in Log4j that was being exploited was being inserted in other people's packages. So can your scanning tools look for random classes? What happens if the class has been obfuscated? What happens if the method names were changed? It may still be vulnerable. So how good are your tools at spotting those sorts of situations, right? That's pretty bad. And then there are other things like internal code. You wouldn't perhaps not be surprised to understand that occasionally the packages that you have internally that you've developed can end up, well, the names can end up on a public repo because somebody's figured it out. They've added some remote code on repo thing, and then when you do your download, suddenly it doesn't download the internal version of something. It goes to the public repo and downloads your code. So can your scanning tools deal with the locality? Can it work out that this code is coming from the wrong place? So, that's what we rely on, right? And there's a whole bunch of other stuff that scanning tools are supposed to detect. And the problem is that we don't really look at it like that. We just go scanning tool tick. And some companies are lucky and they've got good ones. Some companies have just got an open source one. It doesn't tell them very much, right? And now the other thing, of course, is forgetting even the technology about trying to find this stuff. It's where does the data come from? Who is it that says, here's how, here's who provides the bytecode pattern to look for, right? Who writes the tools to look into these things? Who provides the data? Who looks at the CVEs they come through? Somebody has to do all that work. And unless you've bought the right product, you don't get that, you get something less. So that means, coming back to the problem we have, is that many people think they're safe when they're not because they don't understand what the tools are trying to do. Right, so this is where SBOMs come in. And I can't remember if there's another picture. Yeah, we'll come to that in a sec. Okay, so all this uncertainty means we need to flip the equation. So what an SBOM says is the SBOM says, look, you don't have to do this work. You don't have to figure out what you've been given. You don't have to look at your transitive dependencies and work it out. The piece of code that you download should come with an SBOM that tells you all the ingredients. And if that SBOM's got ingredients, then those ingredients should have SBOMs. So the idea is to flip this completely on its head and say you are going to get an SBOM, and that SBOM is the ingredients of the thing. So if you pull a jar file off Maven Central, you would like to get an SBOM that tells you what its dependencies are. And if you do it in the right way, these things can be signed, they can be linked together. You can prove that the binary that you've got has only these things in it and what its dependencies are. So you don't have to rely on scanning. You can actually now flip this around, which is why SBOMs are such a big thing. So I'm going to talk about the Maven Central one because, hey, Maven Central now has SBOMs. Let's go over there and we'll see what happens. So I want to show you this tool. So if you go, here's the test. Ooh, okay. So at Maven Central, this is live, a real demo. Let's pick something. Commons IO. What do we get? Ha. I hope your demos are going to be faster. So we're running on. Please, is it? Picked the wrong one. Okay, no code. Let's go back. What else we got on here? Oh, let's go. That's bound to have one today. Jackson, of course. Yeah. So Maven Central is keeping track of a whole bunch of stuff, and let's pick one. Right. So now, from one of these things, you can get a SBOM, which of course I've got to figure out where it is now. Where is it? Where's the SBOM link? I'm going blind, I can't see it. Well, look, I'll show you something else that's similar. So, sorry?
That sign says bomb doctor report you. They're close to your cursor.
Yeah. No, that's the bomb doctor thing. I've lost the SBOM thing. Anyway, the point is, you can go down on SBOM. But I wanted to show you bomb doctor. So this is another this is a tool related to Maven Central. What I wanted to show you was, if you've ever tried an SBOM, it's just this what it is. It's a recipe. And there are two formats. There's an XML format called CycloneDX, and there's an SPDX version 3 is coming soon. But they're the basic two ones. So this, again, was not the greatest thing. Let's go back and pick something else. Let's pick something big. I'll tell you what, we'll go back one. See, it's live demo. Does that work? Well, you can see you can go to this thing, and the idea is you get a graph of your SBOM. So those of you who've already tried getting an SBOMs, you want to be able to visualize it. You can do this either by going to the repo and going directly to it, or by generating your own SBOM. And that's a pretty straightforward Maven plugin, and there's Gradle plugins. You can do this, and you can just generate one of these SBOMs. Yeah, should have just done pictures. The objective, though, is for you to be able to visualize the SBOM, and in fact, it's your dependency tree. And we're tacking onto it not just the relationship, we're also tacking onto it all of Sonotype's vulnerability data. So now you can go to your SBOM and you can see what state you have in terms of vulnerabilities, not at a high level, but actually down at a particular jar level. Okay, this is getting even worse. Let's see. Do I dare do a refresh? Okay. Anybody got a long cable? Okay. I think I'll hand over you to do the other tools.
We can come back to this.
And then we'll come back and I'll see whether we can do that. Yeah. So just to let it off, this is a cut and paste of the thing. You can go to BOM Doctor, which is this other one, and you can upload your SBOM, or in very tiny letters, it says here how to actually do a generate SBOM from your Maven project. But BOM Doctor's got all the instructions if you want to try it. Cool. Right, I'll hand over to you, and I'll see if I can get a BOM Doctor thing to come up.
Okay, great. Thank you. It loaded, but it's not what you would hope.
Oh no,
hope to have.
yeah, I've got a better one.
Okay, great. So, in the meantime, we have to see how we can get that in real-life projects, because even though it's nice to see it visual, we need and we like terminals. So I put together three tools in order to see also in terms of comparison what it means to have different scanners. On the right-hand side, you can see Sift, and this one generates SBOMs from pretty much everything. For this particular demo, we'll look at how it generates from Docker images, but it can also have generate SBOMs from jar files, from Rust crates, from Go packages, I think Python as well. And you can also point it to a directory, and it will just scan the directory recursively and come back with something out that looks like an SBOM. And in terms of different formats, as Steve mentioned, there are it supports 4. The 3 official, actually 2 of the official ones, CycloneDX. The SPDX one, it has an own format that is by default the one that usually they provide. And on top of that, you can change from one format to the other, because if the US mandate asks that the formats are interchangeable. And then Gripe, that is coming also from Anchor, like Sift, it's a vulnerability scanner, but that actually incorporates also Sift. So if you go and point Gripe towards an image, it will just come out with a bunch of vulnerabilities if they are, and if you're lucky, you'll not have any of them, because some people write code without failure. And the one in the middle is an open source one that is just getting started, and they use at this point only 3 options in terms of vulnerability databases. And what I particularly like about it, they implement an EPSS score, so a probabilistic score that helps you put an order into the way how you solve the vulnerabilities based on how probable it is that it will just that vulnerability is gonna be exploited. But let's see them in action, hopefully, because this one tries to connect to the internet as well. So typically, can you read that or? Okay, so you can go with Sift and just point it towards a Docker image, but I'll not do that, because if I'll try to do it, we'll just stay here until morning and probably we have something else to do as well. So I'll just use an SBOM that I created earlier, and that's for a Docker image that was on top of it earlier. And what it yields is, okay, the type of library that you see, the library, the name of the library, the version that is installed, whether it's a Java archive or a Debian file, the CVE that is linked to the MVD database, and then on the right-hand side you can see the vulnerability and the CVSS score of that one. So pretty much that's the way how it puts it. This is the table format that they have by default, both Swift and Gripe. But you can do it also in other formats like, for instance, JSON. It will just do the same thing, but put them in a easier format in terms of digestion when it's about machine. And then to see how Bomber is doing as well. With Bomber, there is a caveat because they are currently using the OSV index, and because the bulk version of that one is not working as expected, it will just take a long time. So I'll just get it started, but then I'll show you a picture that I did earlier, just in order to save time. Okay, and then we'll do the same one, and you can see that, as Steve mentioned, that they are not all equal, because actually what happens is that this one will have not that many vulnerabilities. If in the initial example using Gripe there were 70 vulnerabilities, in the high and critical part of the classification, this one will come out only with 1 or 2. Okay, so let me just go to the outcome that there was earlier. So as you can see, it just has 10 high and moderate in this particular case. It lists them, but the main difference between the two of them is the fact that Gripe uses, I think, 10 databases, and it aggregates all the score and it takes out the duplicate ones. But the database that it's imported is much more important than actually the tool, because the tool takes the information, scans them, and then puts it in a nice format. And on the other hand, Gripe is storing the database locally, so it just checks, like the dirty flag, whether there is more information available or not. The other one is always connecting, and as you can see, it's just still trying to do something about it. Okay, in terms of tooling, this would be, there are other options as well, but we have to go to the doctor as well.
We can show the bomb doctor again. If you go back to your slide, yeah.
Okay.
Yeah.
Where is it?
No, if you go back to your slides, bring the slides back up.
Yeah.
Yeah, because it's actually we can do the sample one. So because I forgot that Bomb Doctor comes with a demo. Ta-da! Sample project, yes. Your system's much slower than mine. Okay.
It's on foreign soil. It's not used to
It's on foreign soil. Yeah. So the point was, having got an SBOM, you can visualize it. Now this one you can see just about is that you can see all the different dependencies, and you can see the dependencies, and they wire up. And there's some scoring on SBOM on Bomb Doctor, because associated with this is we're giving you information. So for instance, this one's red. There it goes, at the side there. So this one is red because we have a scoring system, which is another completely different talk, but this is all about trying to make you aware of the challenges you've got. And we're also trying to get better at giving you update information. So you can use Bomb Doctor to go, what if I update that? And we'll go, bad choice, because that will give you a breaking change over here, or the good choice. So we're working on those sorts of things. The thing is even if you're not really into using SBOMs at the moment, the thing about Bomb Doctor is that because you can generate one for your project, you can load it up and actually visualize all your dependencies already. So you need to worry about SBOM. Now, the thing that's important to understand is we are generating SBOMs. You saw, what was the generation one tool? Forgotten.
Sift.
So Sift generates an SBOM. Now, there are lots of things like CycloneDX and generates SBOMs, and what they're doing is they're looking at the base data that's in your POM or whatever, and they're generating that manifest for that thing, right? The idea is that you're not going to do that for somebody else's code. Somebody else will do that and publish that SBOM. We haven't got there. What we're at to the moment is people are getting into the hang of generating SBOMs. So when you see SBOM scanning, it's not the same thing as what a vulnerability scanner is going to do, which is going to go creeping around. It's going, give me an SBOM, I'll go look up in this database what vulnerabilities you've got. Okay. So this begins to get us closer towards that goal of you not having to do scanning tools, you just have to worry about, I can run one of these tools against my SBOM, and because eventually my SBOM will be linked to the SBOMs of the dependencies I've brought down, I'll get all those as well. And therefore I will have a complete picture, just sort of like Bomb Doctor, of all the things that I depend on and what their various vulnerability status is. So that's what we're trying to get to, but we're not there. At the moment, we're just at the basics of just learning how to generate them and look at them. Yeah, cool, right. Was that it? Oh, you got those ones. Do you want to talk about the last few? We've got 5 minutes. Do you want to do the last? Talk about the last ones.
So there are a bunch of other tools that you can look into, and these are an example of them. Of course, Kubernetes is everywhere because that's trendy, and then we have to look into that. And then on the lower side, you can see the two of the ones that are also working on the formats. It's the SPDX, and then there is the OWASP one from CycloneDX Maven plugin, where you can use them to generate them. And obviously, Microsoft works on that as well. There is a nice article attached to it. You can see more about it in there. And pretty much that's it.
That's it?
Yeah.
Aha. Yeah, we have 4 minutes. Any questions? Yes.
We use internally Windows 3D for microsecurity. I don't know if you know about it, and if there's something that has similarities or some differences from the things that you showed us today.
So what was the name of the tool again?
3D by it's called Security, I think the company.
Yeah, no, I don't know. Most of these are pretty straightforward. Because if you think about it, at one level, the moment, because we're just generating SBOMs from the things we have and we're not linking to other ones, they are taking a POM or a package JSON file or a whatever and have it in a different format. And so many of these things are like, oh, that's the SBOM tool for that community. So these are even a Kubernetes one. So most of these things are like that. And I'm not surprised that other people will start producing these things because we glossed over, and you've probably seen it, the SBOM as a descriptive thing is much, much bigger than a POM. There's a lot more information in there, and there's lots more information. In theory, there's a lot more ability for information about what makes up your product to be inserted. So, those things are coming. But for some reason, you mentioned, I can't remember the words you said, but for some reason, everybody wants to write a tool to create an SBOM. So.
But you can, in terms of tooling, you can go on the site of CycloneDX and SPDX. There is a whole taxonomy there, and there are a couple of hundreds of tools based on categories and so on and so forth. But looking into tooling and having as example the two of them, Bomber versus Gripe, there are basic differences in terms of what they use, because all of them will just compare against the vulnerability database. For instance, Gripe has on their GitHub project page, on the README, there are listed like 10, I think. It's about Alpine DB, Oracle's vulnerability database, and so on and so forth. And that's one thing. And the other thing, it's about speed. As you've seen, Bomber is going online always and doesn't store that locally, doesn't cache that. And I think that's where the difference is coming from. So the Aqua you mentioned, right? Well, Aqua is quite known from what I know in the security space, so I would expect to have something interesting from them. But I think regardless of the tool, these are the things that I would look for when looking at it. And it's about also the formats that you strive for. And I think that's important because, for instance, Bomber provides you a nice report, and it's also this EPSS score, because in the end, they are just digesting information. They are just a pipe in a longer. Oh, and they can be easily integrated with GitHub Actions. Both of them have actions that are working with that, and probably that's something that cares.
Yeah.
One more.
One more. Yeah.
Hi, thank you for the session. I have a small clarification. Can SBOM identify tampered jars, or do we need to rely on jars?
I'm sorry. Can SBOMs be tampered with? Is that what you said?
Can SBOM assume I have a jar and I'm distributing library, and due to supply chain, my jar gets tampered. Supply chain attacks.
Yeah. Okay. Good question. So how do you know? That's another story. So the SBOMs are going to be signed. You should look for things called SIG stores. You'll see SIG store as a thing for storing SBOM signatures and SBOMs themselves. But that verification process of proving it is another story, and you want to look for a thing called reproducible builds, which is where people are trying to allow you to reproduce be able to build something and get exactly the same binary as the provider. That's another different tiny story itself. But you're quite right. This doesn't solve, right now, there's still a load of problems out there. And the most obvious one is that these things aren't joined together. So if you get an SBOM for a Docker container, the chances of that SBOM having all the details about the Tomcat installation you've got, pretty minimal, because these tools aren't wired up together. Anyway, well, time's up because it's flashing at us. Thank you so much for listening. And if you want to talk to me, I'm around all day and tomorrow. You around tomorrow? Yeah, so we're around. Thank you.